Welcome everybody to our talk today, Smals Open to a Shift. So I'm going to tell you something about the Belgian e-government's journey to platform as a service. So I will start by shortly introducing Smals because chances are relatively high that most of you never heard of it, even the ones who are living in Belgium. But Smals is an in-house ICT provider for the Belgian government. So what we do is basically we delivered shared services for public institutions in different service offerings. So we do software development, the complete stack. We also then deploy that on our infrastructure. We have our own data centers, and we not only host them, but we also deliver the operational support for that 24/7. And for those institutions that have their own IT department, they can also get people from us that we are lending out as a staffing offer. Why do we do that? The main purpose of that is that we can create a cost-sharing model for these different public institutions, because we can share things like we use the same technical standards to develop our applications on, and if we are all together, then we can do the negotiations with the different vendors together, and we can apply some economies of scale. We can create services that will be reused over different public institutions. We can provision the machines in a flexible basis. If one institution doesn't need their infrastructure anymore, we can use it for somebody else. And very important as well, the knowledge remains in-house, maybe not in the institution itself, but it remains for the government. So it's already clear for you that I'm not going to tell you something brand new of some technology. I'm not going to show you some code, but I'm going to tell you how we, and as this business, are looking at the new evolutions like a platform as a service and why we came to that. So what is our business as such? So we are doing these shared services, but we are doing them for some time now. We have been around since 1939. We do mainly social security, so you have to think of things like your pension, your healthcare, your paid vacation. Most of the Belgian citizens who are here in the room, they will have some data in one of our data centers. So we have been around for some time. I can assure you that luckily the photo that we have there is not our current infrastructure. We have evolved quite a bit, because also in the government it's maybe not the most sexy business, the most sexy kind of industry, but we also have our challenges. So if you look about Smals today, as you're probably aware, there's a strong pressure on the government budget. So we have to get more efficient to do more things with the same resources, and we can't back down on our on the quality level, because all the applications that we have, they're all mission critical. We really have applications that if they stop working, all the pharmacies in Belgium, they can't distribute medicine anymore. We have applications that handle things like when somebody needs a new organ, and somebody died and they want to transfer the organ to another person, they have to consult our databases. If our databases are down, we risk that the organ is not suitable anymore to be implanted. So it's really mission critical information here. We already had some talks about resilience where they jokingly said if the service is down, people die. But yes, we do have those kind of applications. And as I said, most of you will have some data in our data centers, and probably you don't really like that your neighbor is able to find somewhere on the internet how much you earn and what your medical conditions are. So privacy for us is really important. So how are we going to keep up this level of quality with the strong pressure that the government is putting on our budgets? The only thing that we see fit is that we increase our collaboration, that we work together and find the correct people to deliver the services independently from which institution they work on. So we have started this big ICT synergy program, which is building a community cloud called the G Cloud, for the government cloud, where our aim is to deliver on different levels these shared services. So an infrastructure as a service, a platform as a service, and also a lot of applications that we will be distributing as a software as a service offering. And interesting for us is that this platform as a service offering is also moving to open source. The platform as a service itself is built with open source components, and we are also using that to introduce more open source components into our solutions. So let's talk a bit about that and how we came to take this decision. So in 2014, we still had a rather traditional infrastructure, which was based largely on WebLogic 10. And WebLogic 10 was a version that was end of life, so we needed to migrate, mainly due to technical reasons. But before we started embarking on this large migration path, we first had a look at our business, because, are we taking the right approach for that? So let's look at our business. So as said, we are an in-house shared service provider, but in fact we're really like a car manufacturing plant. Because if you want to get something done at our site, it doesn't happen overnight. You have to do different steps to get to your result. And those different steps, we will perform them in sequence, like they do when manufacturing that car. And because they're all rather complex, not everybody can do it. We have specialists to do that. And of course, for our customers, we are flexible, because we have to. You can order each kind of car that you want. We even have 6. And we're even more flexible than that. You can have it in any color that you want, as long as it's black, as this great IT guru once said. And you already see that, okay, standardization, of course, is a good thing to keep your costs under control, but one thing we also realize is we have to kind of be aware that we are not taking everything for a nail, because the only thing that we have is a hammer. So yes, we were flexible, but our infrastructure was limiting the flexibility that we had. So we looked at our solution. Is it a good solution? And yes, our solution is the best in class, or rather it was at the moment that we created it with the technology at that moment. So it was best in 1910. But since then the world moves on, and these customers, they are starting to ask these fancy features. Can you add a windscreen? I need to have an airbag. Safety belts are kind of needed at this moment. And yes, customer comes first, so we do that. We optimize continuously our process, and we automate things, and we're really capable of delivering those things, and it looks like that. So we have the features, but it's still a Model T. It's even still black. Well, okay. So we thought maybe we have to look a bit further. So we talked with our customers, and we said, okay, tell us what is now the main thing that you need in this solution. And they say, well, it's really simple. It just has to be fast. That's the car that I want. And then you talk to another one, and he says, no. It has to look sweet. It has to look sweet. And then the third one says, no, you got it all wrong. It's capacity. I need capacity. And the fourth one says, no, you got it all wrong. I need capacity. But that then sort of meant something different there. So yeah, we have to cater for a lot of customers. These institutions, they're all different. Don't they agree upon anything? Yes, they do agree, because security and reliability, they all agree. That's simple. And even those that don't agree on security and reliability, there's really one thing that they all agree upon, and that is the price. So that was our mission. That was what we had to do. And we saw directly, okay, if we are simply going to replace this application server, although that is a key component in our solution, that won't cut it. It's just not enough. We need a solution that is ready for change, because we have to adapt it on the go. And yes, it has to be this reliable, secure solution, because that's our business. We can't do anything without it. And of course, it has to be cost efficient, because otherwise we are not meeting that demand for these budget cuts. So we, at that moment, had a look at what was available, and we chose to go for a platform as a service solution, more specifically the Red Hat OpenShift Enterprise. So just for those who don't have an idea what I'm talking about with all these IaaS, PaaS, SaaS things. So as a whole, if you're creating your stack, the easiest part is the on-premise. You do everything yourself. You have full control. You can make all the decisions. but you also have to do all the work. So it's nice for one thing, but we are Smals. We are not delivering these setups. What we want to do is deliver value to our customers. So do we really have to control everything? Then the infrastructure as a service says, okay, instead of creating everything like this customized Model T from scratch every time you start again, no, start to organize these things, take this lower level and make it as a service. Bundle all these physical servers, handle this networking at the same way, so that your developers and your application deployers don't need to think about it. It becomes a service. Platform there says, okay, that's good. Virtualization is fine, but you need even more. It's not enough, because in this virtual machine, you have to handle the life cycle. You do the updates. You have to handle the configuration. Your application does not run natively in a virtual machine. You need an operating system that is customized, a middleware layer, and a runtime. And that is what Platform as a Service is adding on top of the infrastructure. And that's what we wanted to have, so that we can package our solutions and offer them to the customer as a software as a service. You don't think about it. You just click, you start it, and you're happy with that. So for a development point of view, did it promise something? Yet it promised a lot, because Platform as a Service says you can get an environment instantaneously. We all have been at our managers and say, okay, I want to do this demo, but I don't have a machine. Can you organize a machine for me? How long do you need it? I need it for a day because it's only for this demo. But then you have to follow this procedure, this acquisition. You have to fill out those forms, and in the end you don't do it. Or even worse, you take an existing environment, you scratch it, you install it there, and then some days later you have to redo all that work. Now with Platform as a Service, they say, no, if you want an environment for a day, you just create it. And that environment is the real thing. It's not, it works on my computer. The environment that is created in development will be exactly the same as the one that is in production. So if it works there, it will work in production. And also, you don't have one machine, but you can specify, I want to have it in a clustered mode, so that you can do all those nasty clustering tests up front. You want that. Also, most of the developers don't really like to do paperwork. So if they have to organize a deployment and they have to do it in advance, and they have to fill out all these nasty descriptors that have to be changed, they don't like that. And if they don't like it, they make errors in it. So what is Platform as a Service promising us? Okay, we'll deliver you some delivery pipeline, and we will just automate it. If it works once, it will work again. And linked to this paperwork thing, it's nice to have all this information in 10 different tools, but it gets messy. You lose data. So Platform as a Service says, okay, we will also version these things, so that you still know what was demanded. But if you want to deploy everything, it's not only development skills that you need, because in the end, you are deploying into an acceptation or even a production environment. So all this knowledge that the operation guys have, that has to go into this configuration that will be deployed by the platform. So the promise for us was also that this Platform as a Service would be, yes, an enabler to go to DevOps, to bring the operational department a bit closer to development. So for those who don't know OpenShift, this is the overview of the version we have currently running. So the main idea is that you have a central broker that is doing all these management and orchestration tasks. And your applications will be deployed on the nodes. The nodes are the real machines, and the ones that are handling your workload. And as a developer, you just code, and you can put in your code directly into a Git repository that is even shared in the platform itself. And based on the type of deployment of the files that you submit, it will decide whether you have to build it. So if you do a source code, it will build it. If it is a binary, it will deploy it. And then what is running on these nodes are containers. Containers called in OpenShift version 2 gears. Why are they called containers and why isn't that Docker? Keep that question. We will answer that later on. So our developers now have this platform. They have their code. They can push it. It will be compiled. And that's it. Yeah, development is happy. But it wasn't enough because then we don't have our application yet in production. If we want to do that, we have to do a mindset shift. And not only for development, but for all our teams. So what was this mindset that we had to change? First of all, we're not talking about machines anymore. In the old days, everything was centered about the machine. You had to know where it was, you had to know the name, you had to handle all the networking stuff, the DNS stuff, and you had to create all these processes to start doing something with a machine. And you're not interested in a machine, you're interested in an application. And because we were modeling our process around these machines, it was very difficult to guarantee that all these machines that we had in all these different environments had the same state. Because if somebody forgot to create the tickets or they misinterpreted it, it would be possible that you had your configuration update in development, but that they forgot it in production. So then you tested it, it didn't work. So very important with the new system, all the environments are the same. If it works in development, it will work in production. All the tools that we had to support this difficult process, they are replaced. They are replaced by the platform, because what we now have is an application that contains everything to do the deployment. So it's the code, it's the configuration, and we put that together in this versioning system, and the application describes everything. So you don't need all those other tools anymore. Manual interventions, thing of the past, because it is a container, which means you don't modify it at runtime. If you want to modify it, you have to do a new deployment. And that's way you're sure that it will be executed at the right moment. And also, I showed you, we were kind of this car manufacturing plant. We had one process for the complete enterprise. But you also saw that we had to deliver different kinds of cars. So instead of going for a new car manufacturing plant and create one new enterprise application, that enterprise-wide solution that handles everything, we said no. What we want to do is we want you to deliver a standard solution that handles most of the topics, but that gives you also some room for extension, where you can add your specific needs. Keep it open. But to do that, to customize this standard solution, to know what you have to deploy, yeah, you can't do that if your responsibility is separated between the development and the middleware team and the database team and the server team and the network team. Because in the end, they all have to work together to have one working application. So at this moment, all the teams have to communicate more, and the result is what is now called this self-contained application. So when we roll that out, very important, we aimed for full traceability. So the platform comes with a security model that allows you to have personal accounts, and we really embrace that. We want that every change that is made is clear, that we know who did it and when they did it. And that's clearly not for finger pointing. It's to be sure that you can contact the responsible who did it and get in touch with him, and don't have to search for hours and hours. Did something change? If something changed, who did it? Is it with a general account? No, personal accounts. And this security model, we took it even a bit further than only the platform. Because, yeah, we also have a separate storage of our log files. And those log files also have an access model. So what we did is we created one security model that was valid for everything, and we applied that also on the logs. So now for a development team or an operational team, they have to get their permission to work on a certain business domain. And in that business domain, they have access to the resources of the platform and also on all the things that are besides it. One solution. And this standard solution, we really believe in that. So to say it in Java, don't make every method that you have final from the beginning, because sometimes it's difficult to know in advance how your solution will be used. try to make something that does the basic needs, but leave the room and try to capture what they do with it and improve on that. And what we already did, because we knew that this was only the first step and that we would want to open it up later on to multiple clients, even while we were still setting it up internally, we did it on a multi-tenant mindset. And that really helped us as well to get the clear separations. Even if you do it internally, if you act as, okay, my different business domains are different customers, would I open it up if it was really someone that I didn't know? If the answer is no, then it's maybe also a good idea to do it inside your enterprise. That way, the security guys are happy with it. So, 1 year later, are we happy with it? Does the platform keep its promises? Yes, we can say that. So our developers do create the environment for themselves. We do see that because we had an infrastructure as a service offering where they could create a machine, but they had to do a lot of things themselves. What we see now is that we have dozens and dozens of containers running on these infrastructure as a service nodes. We have 10 times more containers running than we had infrastructure as a service machines. Why do they do it? Because it's so easy. Do they have to create some things in their application? No. An application remains the same. The application sees your application server. So the impact that this platform as a service has on your development team is minimal. They don't see it. Everything that runs on a standalone server on your local development machine will run in the platform as a service. The only thing that you really have to do is to extract all these configuration, because you don't have anybody anymore who is going to open your archive and change your descriptor. That you can't do. It has to be automated. So we were coming from a traditional installation where we sometimes changed our descriptors. Now they can't do that anymore. So that requires some migration effort, but that effort is definitely worth it. It makes your configuration easier, you avoid duplications, and the benefit is that all the configuration of your complete application is centralized in one location. That's nice, that's readable. Is it something that your developers will see and 5 minutes later they can work with it? Yeah, some of them will. But we have to be honest, not all. For some it is a learning curve. Some developers also discover that there's something else than their local PC. They're not aware of that. They start thinking about this. Oh, I have to package that. Why? Yeah, because we're putting that in production. Oh, yeah. So it creates awareness. And we also push them, now that they have their environments, to do those tests earlier. So they are not only aware that there are different environments, but they are going to use them. They are doing the performance tests together now. Before that was on an own infrastructure. They were not implicated. Nobody saw it. Now we are doing that together, development with our performance team. The clustering tests. Sometimes we got developers who said, yeah, I know that error, I can't test that. I don't have a cluster. Yeah, now you have, and you have to. So we really demand from all our developers that they dry run their deployments before they hand it over to the operation guys. You can't simply throw it over the wall anymore. You don't have the excuse. You had the tools to do it. So let's see the tools that we used. So the OpenShift v2 had a very useful feature for us, which was the auto-idling. The auto-idling means that you can tell the developers, just create it. If you don't use it anymore, it will be suspended automatically. So you don't have to chase them every minute to say, did you suspend your machine? Do you really need that? No, they simply create it. If they need it 1 week later, not a problem. They simply touch the application via their browser and the container comes back alive. The only thing they have is, let's say, some seconds of latency in it. They don't bother anymore. But as I said, we see that the number of containers that we store on this infrastructure of a service virtual machines is huge. They are not all running, and that's a good thing. Scaled deployments. So whether you deploy it on one instance of on one container, on 2 containers, or on 17 containers, it's the same. Because it's this platform as a service who is hiding that for you. And it's doing a great job there. So it has, out of the box, this opportunity, this functionality not to start the deployment on the second instance of this container when the first one is still down. So you get these deployments that are guaranteed to be without impact of your users. And again, the deployments that your developers do on a single instance, on a single gear, it's exactly the same deployment as your operation guys will do in the clustered environment. We also had this platform first for our Java development. We run JBoss on it. But quickly we had some other departments in the company who said, yeah, that's also kind of interesting because we have the same needs, but we are running on PHP. And since it is a container, it is multi-technology. The container shields what's in it. So we can use in this tool exactly the same platform and exactly the same principles with the PHP. Our Java guys can start and stop PHP containers if they would want to. So standardization, we didn't give that up. We do have standardization, but we have standardization now at a useful level, this container. We don't have standardization into every little detail of it. The operation is run on a container, whatever is in. And this traceability, I said, yeah, we don't do that for finger pointing, and it really helps, because now if something does go wrong, because also, let's be honest, it does not solve all your problems. If it does go wrong, we can look together at it, and we find the problem much easier. So we don't have these discussions that don't use arguments or evidence that something is wrong. It's your fault, it's your fault. No, we look together, we find the problem, we correct it, the service is restored, and nobody gets into this panic and battle mode, and we have less finger-pointing meetings. So about the process. As I said, we automated a lot of things. But since security at our side is really important, we have to be rather careful with things like passwords, key stores, and things like that. So our aim in the beginning was, okay, let's remain realistic. We won't be able to automate it for the full 100%. We do it for 95%. And what we learned now is that it seems that all the problems now move to the last 5%. That's mainly an ID, because all the problems that would have produced itself before that, yeah, they didn't, and you only see what is going wrong. But if you are doing it, your aim should be to go for the full 100%, because everywhere where you leave this human interaction, where there is a handover of responsibility, you have room for misunderstanding, you have room for an error. What we also learned is that, yeah, it was nice, this idea that we had. We're not going to create this new one-size-fits-all. We are going to create you a basic solution that you can extend. And some people really love that, because they say, okay, now I have the flexibility to do that. Some other people say, okay, but how do I do it? Give me a straight answer. Tell me, how do I do it? And then you say, well, that depends what you want to do with it. You can do solution A, you can do solution B. It was a bit of a surprise for us that not everybody was saying, great, now we have more flexibility. Some said, okay, straight answers. Related to that is that, yeah, you're moving to a more flexible solution. More flexibility also comes with more responsibility. If you are going to let your developers create a part of your production configuration, that has to be production quality. We also saw that some people, they rather liked that they could give it to operations, and if it didn't work, yeah, it was the operation guy that, yeah, I described it. You see, I described it. He didn't understand it. not my fault. Yeah, it is your fault. You have to make sure that the message comes across. And now, the message is coming across when you create the proper configuration. So the responsibilities are kind of shifting. And that is not a technical issue. That is culture change. And you saw the title of the presentation was Our Journey to Paas. It's not an event. It's not you decide on the Monday morning, now we are going to implement platform as a service, and ta-da, now it works. No, it's a journey. And it will take some time. And it will take some time before the culture really changes and everybody grasps it. What we also can tell you there is it's probably not a good idea to do it directly with your complete company at once. We also started with a couple of teams, and you learn along the way. You have to treat it really as a migration track and go at a proper speed. The model that this platform as a service offered us. What we saw with the tools is that being a shared service provider as we are, we do sometimes need other features than just being on-premise. As I said, even from the beginning, we aimed for a setup that is multi-tenant, at least inside the different business domains in our organization. Some features are not there, nor not there yet, or you still have to make decisions on how are we going to organize them. So be aware that if you choose a platform as a service offering, even if it says, yeah, we can do on-premise, be sure to look on what you really need. For us, security was a key issue. We needed a proper security model, and that one was in, and we could use that not only in the platform as a service, but we could use it a bit wider. Also, an interesting thing that we learned was, once you start introducing a new model, one of the first questions that somebody is going to ask you is, how much will it cost? And then you have two possibilities. Either you can tell them, okay, it will cost you less, and you're great. But if some customer is getting a bill that is a bit lower, then probably another one is getting a bill that is a bit higher. So these pricing models, they are important. You have to know the pricing model of your organization. You have to think in advance what is the impact on it, and you have to communicate that really clear. Because if you don't, people simply won't adopt your new model because it's not clear what will be the price impact for them. And what we saw in this model from V2, with the gears that we showed you, it had one feature that was both its strength and its weakness. So the strength is that the application model in V2 is really clear. It is really simple. In the version 2 of the OpenShift platform as a service, you can do a web container, and you can add an optional database. That's it. And that's great. And that's easy to start with. It's clear what you have to do with it. But even we, in 1 year, this platform was there, we still needed more flexibility, because when the PHP guys came and they said, can we run our PHP on your JBoss platform? We said, yes, that's no problem. But then the people come and they say, okay, nice, I have a batch job. But it's a bit stupid that we now have to create a big machine that simply has to do this little batch processing. Can't I simply do this batch in your container? Well, that's difficult because the batch is not a web container. So you had some issues there. And then some other guys said, okay, that's nice. So you are able to create an application server with a database behind it. I only need a database. So I create this database container. And then we had to say, well, in V2, it's difficult. Luckily for us, there is an OpenShift v3 coming. And there we see a familiar term, Docker. So you probably all visited one or more sessions about Docker and Kubernetes in the past days. But for us, what is Docker going to add that we don't have? It is this flexibility. So the gear model that we had in V2, which was an OpenShift specific construct, is now being replaced by Docker, which for us makes it a lot more easy to modify these containers, to create our own containers. And we can also use it as a platform to host services in a more software as a service way. So on the Docker Hub, you find a lot of images that are ready to be used. We can download them, we can evaluate them, and then we can simply run them on our platform. So overall, V2 promises to be a lot more flexible than the V2 that we have currently in production. So all those questions that we had about the different workload types, can I do a simple database for development in it? Yes, you can. Can I run my batch in it? Yes, you can. And also one of the main advantages that we saw is in V2, the containers were separate, but the images were shared. So you only had one type of image per node, and all your containers had to follow this same upgrade cycle, let's say. You couldn't have on one node 2 versions of the JBoss container. But that is what we want, because we don't want to do these big migrations again, where we stick like we did with WebLogic 10. Why did we stick with WebLogic 10 so long? Because it's difficult to migrate, because we have one shared application server with a lot of applications on it. So if we want to migrate one, then we need a different machine. Or we have to upgrade all these applications at once. So what we really want is more fine-grained control. We want to be sure that we can keep the application with its application server independently from the other ones that are installed on the same node. And that we can do because the Docker is providing us that level of isolation in it. So let's see how the architecture looks like for V3. The main idea is really similar like we had in the V2. You have a central component who is orchestrating all these things. Now it's not called a broker, but it's called a master. You still have nodes, but instead of these gears that were running in V2, now they are simply running Docker images. And you have some services on beside it. So you have your persistent storage. Of course, you want your container also to be able to store some files. You have a registry to store the images in, and you have a routing layer that handles all this routing, load balancing kind of stuff. So again, we think that is really an improvement to version 2. In version 2, they had this load balancing in the gear itself, so in the container. In version 3, it's pulled out. In fact, we see a lot of things that were in V2 were linked to the container, this custom gear, that are now split up in more separate components. Also in V2, as you remember, the developer simply pushed their code to the container, to the Git. In V3, you simply have an external source control system that can be either Git, can be Subversion. It's all of V3 is more flexible. So, what are we doing with that? As I said, it's a journey. Even we are not at the end after 1 year. So V3 is coming. We are doing a full multi-tenant rollout. So that means that it's not only Smals who is going to use this infrastructure, but our institutions, they will be able to use the platform directly themselves in a self-service mode. And we're not only working on platform as a service, because platform, I think it's great, and it will answer a lot of questions. But I think it is not realistic to think that every application that is out there will be moving to platform, not in the next year, maybe not in the next 5 years, and maybe not ever. You will probably always have some workloads that will remain on a virtual machine. Like with virtual machines, we have the same thing. There are still workloads that will require a physical server. So in the end, probably you will see that your service offering will contain all these kinds. And you have to prepare yourself for this flexible and heterogeneous environment. So in the same time as we are introducing the platform as a service, we are also working on an infrastructure as a service solution that we are doing with OpenStack for being an open source standard solution. But what we are seeing now with the Docker and the offering of V3 is that it is becoming a bit blurry to see what we are doing in infrastructure, what we are doing on platform. I think that in the next year, we will see a lot more, yeah, you can do that in 2 different ways. And again, you will have to decide which one is best. I think that is not a bad thing. Maybe not for the guys who want the straight answers. Here is a problem, tell me how to do it. But we will be getting the tools to choose the right tool for a problem, not the hammer that we had in the first slide. And we're not doing that alone. We are grouping all those initiatives into this government cloud. This government cloud is not Smals that is making it. We are, as a community cloud, doing it together. We have to, because there is so much work to be done that you have to combine the competences that different people have, and you have to think of all these viewpoints, and everybody needs to be represented in it. So, that was my information. Are there any questions?
Yeah. Pricing. We are also, Dutch government also building a cloud. How do you get budget for development machines and stuff like that? What's the financing model internally?
Okay, so the question was, what is the financing model for the development machines?
Yeah,
and
development testing and stuff like that. All the environments.
Yeah, so that's a good question. So what we try to do is to share the costs over the different development projects. We, as Smals specifically, we develop for a lot of different customers. So we create one great one budget that handles the acquisition of and the operation of the servers, and then they are distributed per use. So it's not really a pay-per-use concept, but it goes to the way it's more of a
Do you count machines or gears and then bill that to your different customers?
Yeah, so we are using the containers as the billable unit, and what we hope for in the next versions of the Paas is that we really can not bill on the container itself, but even on the use that you make. So how much CPU you actually use, and not how much CPU that you reserve. But that again, it's a tricky business, because you have to keep in mind that you also, when you reserve things, you already are making costs. So you can't simply reserve things and don't pay for them. So the billing model becomes quite complex. But also there we see that it's not an event. It will change also based on what the information that the platform can deliver us. But the main idea is share the initial investment, and then redistribute it based on how you use it. Yep.
When you delivered your solution on OpenShift V2, you only delivered the final solution, or the platform also to the end customer?
No. So the V2, we only use that internally in our company. So we host their applications for different customers, but it's not an open self-service. So it's for applications that are developed by Smals, installed by Smals, and operated by Smals. So that's the main difference that we do with V2 and V3. We decided that for two reasons. First of all, we didn't want to go too fast, because it has to mature, and we have to know how to work with it before we open it up to everybody. Also, we see, as I shown you, that the V3 is a big change, and it will be more flexible. So it is useful to open up that one and not the V2.
Thank you.
Excuse me. Are you using the same platform for development and production?
Yes.
So developer uses exactly the same platform.
Yes.
Another gear or whatever.
Yes. So they're different nodes. So because we don't mix the containers from the development, integration, acceptation. So they're split per node, but they're handled by a same broker. It's exactly the same version, because we really want to have that guarantee that if you tested it in development, that it's exactly the same in production. So that is really a key feature for us.
I like this G-Cloud idea. Do you know how other European governments are doing? Are we ahead with this kind of concept, or?
No, we're not the only ones doing that. As there was already one of the Dutch government who is doing the same initiative. We also know that the UK is doing a government cloud. So no, we see that a lot of government agencies are doing that, because we all have this kind of same history. We all have the same pressure on our budgets, and there aren't, at least we think, there aren't 50 ways to solve it. So we are arriving at some same conclusions. Okay.
You mentioned that security was a high priority, but on one of your slides you mentioned that you can run directly Docker images from Docker Hub. Aren't you afraid that the Docker images contain backdoors?
Yes, of course.
And how do you deal with that? Do you verify them in some way?
Yeah, so you can directly run them, but we also have different zones in our network. So what we can download from the Docker Hub is, for example, if you find some tool for, let's say, a developer wiki or a forum that you have, okay, that will probably make it into our development zone rather easy. But that one is shielded completely from the outside world. What are we going to allow to run in the production zone? Those are verified containers. So it's not, the message is clearly not that somebody goes to the Docker Hub, finds a new image, downloads it, and 5 minutes later it is in production. No, we do have our governance procedures in place. Also, this registry, we have different zones, different registries, and you have to prove and test and let them verify by our security advisors before it moves on from a repository that is only accessible in the development, let's say, sandbox, until it makes its way into production.
So do you own the servers and the storage? I mean, you are the owner, Smals.
Yeah.
You have your own data center.
So the question is, are we the...
You have your own data center.
Do we have our own data centers? Yes. So Smals has their own data centers, and one of the initiatives that we are doing in this government cloud is also looking at, can we share the data centers between other government agencies? So the idea is in the end that we have one consolidated, interconnected set of data centers, and that the institutions can use them independently from who is hosting it. Because in the end, we are all paid with the same taxpayers' money, of course. Okay, any other questions? Then thanks a lot for attending, and if you come up with any other questions, I'm here, just come and see me.